In today's video, we'll be looking at straight line graphs. At the end, you should be able to know what the two axes are, how the coordinate notation works, and how the formula y equals mx plus c works, and what all of the variables or letters does in the equation. So we can start off with the two axes, and I'm going to start off with the x-axis first. And the x-axis is the horizontal axis, and I always start off with 0, which is in the middle, and to the right of the 0 is all of the positive numbers like 1 and 2 and 3, and it goes on into infinity. And to the left hand side of the 0 you get your negative values like that. So this is your x-axis, and the second axis that you have is the y-axis, which is the vertical one, which looks like that. And then you start off with the origin again at 0, and upwards is the positive values for this axis, the y-axis. And below the 0, below the x-axis, you get your negative numbers, and it also goes on into infinity. How I remember which axis is what is I think of the tail of the y, which kind of looks like this. It hangs down. So that's how I remember which one is the y and which one is the x. And we can move on to coordinate notation. So let's say you want to find the point 1 and 2. And with coordinate notation, it's always in the form x first and then y. So if they give you a point 1 and 2, it means that the x is 1 and the y is 2. So you check here, you go into your x-axis, you find where x is equal to 1, which is over there. And then you go to the y-axis, which is at 2. So your coordinate is going to be there at where x is 1 and y is 2. So let's say you want to find the point -2 and -4. So what I do firstly again is just check and see. First one is x, second one is y. So you go to your horizontal axis, your x-axis, and you find -2, which is over here. And then you go to your y, where it's -4, and it's over here. So when you combine these two again, boom, you find your point -2 and -4. Okay. So next up, after you are familiar with the two axes and how the coordinate notation works, we can move on to the y equals mx plus c, which is also known as the standard form for any straight line graph. And with the y equals mx plus c, y is your y coordinate, and same with the x is just the x coordinate, anyone that corresponds with the values that you put in. And m is the gradient or the slope between any two points of the graph. Because it's a straight line graph, the m or the gradient is going to be the same everywhere. So for example, let's take these 2 points that we have here, which we plotted 1 and 2, and -2, -4. So let's say you want to find the gradient of these 2 points. So let's say that's the line. So to find the gradient, the equation for it is the change in y over the change in x, which you can also say as y subscript 2 minus y subscript 1. Same with the x's. So it doesn't matter which point you use as number 2 or which point you use as 1. What we'll do is we'll calculate both of them, both of the cases, and then you'll see that you'll get the same answer. So let's say you choose this one as x1 and y1, and this one as x2 and y2. So to find the gradient of these two, you can look at the equation and say the change in y, which is y2 minus y1. So y2, which we labeled there, is -4, and y1 is 2. So done with the y's, and now you move on to the change in x, which is x2 minus x1. And you plug those values in again. Then you get -4, -2 is -6, -2 and -1 is -3. The negatives cancel out. You get 6/3, which is the same as saying 2. Now let's say you used the 1 and 2 as x1 and y1, and -2 and -4 as x1 and y1. So then, let's say, again, y2 minus y1 over x2 minus x1. So we used -4 and -2 in the previous one, but we are going to switch them around now. So we'll say 2, -4, and remember to put it in brackets, because with the equation it says y2 minus y1. So it's going to be y2, which is going to be 2, and then negative y1, which is -4. Now, the same with the x's. We'll say x2 is this time 1, and x1 would be -2. So 2 -4 is the same as saying 2 plus 4. 1 -2 is the same as saying 1 plus 2. And you get 6/3, which is the same as 2. So now you can see that it doesn't matter which one of the coordinates you use for x1 and y1 and y2 and y1. You'll get the same answer, because it calculates the slope or the gradient between the 2 points. So it doesn't matter which one you choose as the first or the second one, you'll get the same answer. And so now when we go back to the equation, y equals mx plus c, we know that y is any corresponding y coordinate, x is any corresponding x coordinate, and we now know how to calculate the gradient, which is m. And now c you can just imagine as a number that slides your graph up or down. So let's say you have a graph like this, and let's say the straight line looks like that. And c would be the y-intercept. So let's say here it's at 2, for example. Then your c would be +2, or just 2. And let's say you have the same graph, but it goes through the origin, like that. Then your c would be 0, because it cuts the y-axis at the origin, where it is 0. So then you don't have a c, you don't have a y-intercept, it's at 0. Okay. Now that you know how y equals mx plus c works, we can jump into an example. So let's say find the equation of the straight line that goes through the points or coordinates 0, 1, and 2, 2. So what I'll do firstly is, it's a straight line, so you can use the equation y equals mx plus c. So I'll write that down. And what I would do after writing it down is I would plot the 2 points to get a more visual way of seeing it. So the first point, I'll just call this point 1 and point 2. So the first one is where x is 0 and y is 1. So x is 0 over here and y is 1 over here. So there's your first coordinate. And now you look at your second coordinate, which is at where x is 2 and y is 2. So here where x is 2 and where y is 2. Then you connect them. There you go, there you have your 2 points. So now what you want to do is you want to find the straight line which connects these 2 points together. Now we have the 2 points. If you look back to your equation, you have a corresponding y and you have a corresponding x. So now what you can do is you can calculate the gradient between the 2 points, and which you can calculate as follows. The change in y over change in x, or y2 minus y1 over x2 minus x1. So let's use the second coordinate as y2 and x2, and the first coordinate as y1 and x1. So with y2, I'm going to say that's 2, and y1 is -1. And x2, you get 2 again, minus 0. Then you get 2 minus 1 is 1, 2 minus 0 is 2. 2 minus 0 is 2. So your gradient is a half. So now if you go back to your y equals mx plus c equation, then you can plug in your values, which is going to be a half x plus c. And if you remember, we said that your c is your y-axis intercept, and we already know what the y-axis intercept is. It's 1, because it cuts the y-axis at 1. So now you can finish your equation by saying half x plus 1, like that. And also a different way of writing it, instead of saying half x, you can just say x divided by 2 plus 1. So a half x is the same as saying x over 2. And let's say they ask you a question on the same graph that we did here. What would the x coordinate be if the y coordinate is 4? So where the y coordinate is 4, what is the x coordinate going to be? So I'll do it over here. I'll write my y equals mx plus c equation again. And they said, what would the x coordinate be if y is 4? So then you can substitute the corresponding y value in as 4, half x plus 1, and then subtract 1 from both sides. Then you get 3 is equal to half x. And then you times both sides by 2. And then you get 6x. So now the point on the graph is 6, 4. So now you know when the y is 4, x is going to be 6. So you can write that in there. So now, another example. Plot the graph y equals negative 3x negative 2. So you can already see in what form the equation is. The equation is in the form y equals mx plus c. So I'll write that down again. So you know it's a straight line graph. And if you look at it, you can see that c is negative 2. So just by inspection, you can already see that the y-intercept is going to be negative 2. So you know that 0 and negative 2 is going to be a coordinate on the axes. So let me draw the axes right here. And we know 0 and negative 2. There's your first coordinate. And what I'll do is, you can do it in a number of ways. You can work with the gradient firstly, or what I would do is I would try and find where the x-axis intercept is. And when you want to find the x-axis intercept, you want to make y 0. Because when y is 0 over here, that is where your x-axis intercept is going to be. So if I write the original function or equation again, and let's say you want to find where the y-axis is 0, and now you only have one unknown, which means that you can solve it and then you'll get a value for x. So I'll put it to add 2 to both sides, then you get 2 negative 3x, and then you divide both sides by negative 3, and then you'll get negative 2 over 3 is x. And this means that this is the other point or plot on your graph. So it's going to be somewhere over here. And there you go. There we have successfully plotted the y equals negative 3x negative 2 function.